Problem number 13. A 5-gram marble is fired vertically upward using a spring gun. The spring must be compressed 8 centimeters if the marble is to reach a target 20 meters above the marble position on the compressed spring. So first of all, let's we draw the diagram. When you draw the diagram, that will be easy for our understanding. So you have a spring and you compress the spring. We compress the spring. So this is the compressed position of the spring. Let's take the compressed value of the spring is 8 centimeter. After you compress the spring, you placed a marble on the top of the spring. So this is the marble, and this marble mass is given. And when you shoot this, what will happen? The marble reach the maximum height here. So what is the height of this marble? So when you shot this marble by using the spring gun, you compress the spring to 8 centimeter and you put the marble on the top of the spring, and when you're triggering, what happened? The marble reached the vertical height of 20 meters. That means from here to here, what is the height? The height is 20 meter. Now we have to answer for the first question. So this is the diagram what they mentioned in the question. What is the change in gravitational potential energy of the marble earth system during the 20-meter ascent? So for this diagram, we have to find what is the gravitational potential energy. So that means this is the initial point and this is the final point. That means the initial height is 0 because this is our reference point. Am I right? So this is our reference point. So for our reference point, hi, which is equal to 0. When the marble reaches the maximum height, what is the final point? The final height, which is nothing but 20 meters. Clear? So we have to apply the rule, the change in gravitational potential energy, which is given by the rule, the potential energy final minus potential energy initial. As we know, the formula for potential energy is mgh final minus mgh initial. So we can take the value of mg as a common. So inside the bracket, hf minus hi. So here hi value 0 and hf value is 20 meter. So now I am going to substitute the value here. The mass of this 5 grams, so 5 multiply 10 power minus 3 in terms of kilogram. So and the G value is 9.8 multiply, because the H final is 20 meter, H initial is 0. When you multiply all these, we got the answer for change in gravitational potential energy, which is equal to 0.98 joules. Clear? Now we have to come for the second part. Part B, what is given in the part B, what is the change in elastic potential energy of the spring during its launch of the marble? So this time we are going to find change in elastic potential energy. So for that, better we can draw the diagram again. So when you compress the spring, because this is the compressed part of the spring, which is equal to x, which is equal to 8 centimeter, and you put the marble in the top, right? And when you shoot the ball is nothing but the marble, and the marble reach the height from this point to this point. So this is our reference point, hi, which is equal to 0, and hf, which is equal to 20 meter. But the most important thing, when you are going to find the answer for change in elastic potential energy, the kinetic energy here. So what is the initial kinetic energy? The initial kinetic energy of the marble is 0 because it is at rest before you shoot. But after the marble ball reach the maximum height, your kinetic energy also 0, because after that there is no speed. When the marble reach the maximum height, its speed gets 0. That means the final speed is 0. So if the final speed is 0, the final kinetic energy is also 0. That means initial kinetic energy and the final kinetic energy for this situation is 0. So when you are going to find the answer for this change in elastic potential energy, we have to use the conservation of mechanical energy. So what is the conservation of mechanical energy? change in gravitational potential energy plus change in elastic potential energy, which is equal to 0. Therefore, your change in elastic potential energy, which is equal to negative of change in gravitational potential energy, as we already find the gravitational potential energy change, which is equal to 0.98. So we will get the answer easily. So therefore, the change in elastic potential energy delta US, which is equal to negative of 0.98 joules. So this is the answer for this question. Clear? And now we have to come for the third part. What is given in the third part? We have to find what is the spring constant of the spring. That means we have to find the K value. So for that, how we can find? We can have to write the marble has both kinetic energy and potential energy. Am I right? That means we have to consider the conservation of energy. So that means the marble, when the marble has both kinetic energy and potential energy, so half kx square is the formula for elastic potential energy, which is equal to the mechanical energy. What is the mechanical energy? It's a combination of potential as well as the kinetic. So we have to write half mb square plus mgh. Now you can see when the marble reaches the maximum height, at the maximum height, what happened? Your kinetic energy is 0, because we have to go back to the previous question. You can see initial kinetic energy and final kinetic is 0. Why? Because initially the marble is at rest, so initial speed is 0. When the marble reaches the maximum height, the final speed is also 0. So when the marble reaches the maximum height, what is happening here? Your kinetic energy of the system equal to 0. So that means this part will be discarded. So what is remaining? Half kx square, which is equal to mgh. So when you rearrange this equation in terms of, because we are going to find the spring constant, so here the spring constant is nothing but the k. So we have to rearrange this equation in terms of k. Therefore, k, which is equal to 2 multiplied by mgh divided by x square. Now I'm going to substitute the value here. 2 multiplied by 9.8 multiplied by the height, the maximum height is 20 meter, divided by the spring is compressed to 8 centimeter. So here the x value is 8 centimeter, which is already given in the question. So in terms of meter, we have to divide by 100. So 8 multiplied by 10 power minus 2 meter. So we have to write 0.08, but this is x squared, so we have to square this. When you square this, we got the value of k, which is spring constant, which is 306.25 Newton per meter, which is the unit for the spring constant. So this is the answer for part C. That's it. Thank you.